Yeah, hi, good morning, everyone. So, shall we begin the session? Okay, so first of all, there are some questions. The first question is you have received the assignments and you know the deadlines. So, please submit the assignment within the deadline so that we can issue the certificate to you as soon as possible when the course is finished. Not right now, when the course is finished. Okay, so can anyone tell me what is a module? And my homework is what is the full form of COBOL? Okay, next question is what is the difference between the coupling and the cohesion? My question is to Joseph specifically. What is the difference between the coupling and the cohesion? So, yeah, this is very good. That coupling means the relationship between the modules and the cohesion means the relationship among the various elements of the same module. Yes, very good. So, which is more higher? Yes, correct. Cohesion is more required in the system as compared to the coupling. So, cohesion and the coupling are the two terms that is used in the system development SDLC. Now let's move to the next part, that is the software design and the documentation tools. What are the various what are the various design tools? What are the various documentation tools that is used for the designing, that is used for the management of the, that is used for that is used for the management of the content? So that is the software design and the maintenance. So well-designed modular software is likely to meet that maintenance, reliability, and the testing requirement. So when we talk about the well-designed modular software, that software needs there is a need for the maintenance, there is a need for the reliability, and there is a need for the testing requirements. And three specified tools are discussed over here. One is a structured flowchart, then hippo diagram, and then Vernier over diagram. So these are the three tools that is used for the software design and the documentation tools. So let's talk about the first one, that is a structured flowchart. As you know, what is a flowchart? That is a pictorial representation of the algorithm. That is a flowchart. And another name that is given over here is, and these are the, or flowcharts are the graphic tool that force a designer to structure the software, that is both modular and the top down. So that design the system as a top down approach, that makes the system at the top down approach and the modular. And they provide a structure that can be retained by a programmer who developed the application software. And organization responsibilities also vary from the time to time, from the programmer to programmer. And in some organizations, analysts are responsible for developing module logic, while in others, that responsibility is delegated to the programmer. So some have a responsibility, or some organization have a responsibility to the system analyst. Some give the responsibility to the designer, that is a developer. Some gives the responsibility to the programmer. So it depends on the company to company, how many employees are available in the company, whether it is a big organization, small organization. It depends on the organization or the company. But in every case, or in either case, the programmer should be well versed in the use of the structured flowchart. That must be familiar with the structured flowchart, how to create the structured flowchart, and what is the usage of structured flowchart, and what are the various where the various diagrams that is used in the flowchart. So first one is a basic element. So there are three basic elements that is used in developing the structured flowchart. That is the process decision and the iteration, and there are many similarities that is used or that is developed between the elements and component that is used in the structured English. So there are multiple elements, there are multiple logics that is used with the basic elements, that is used with the flowchart, decision making, and the iteration. Now, how the process will be represented. So a process will be represented in a rectangular box, process symbol that represent the simple processes or the steps in a program. And this symbol represents initialization of the values, input and the output activities. and calls to execute the other procedures also. And the name of the brief description written in the box states that the purpose of the process and this success or the steps that have multiple process boxes. So one of the boxes, one of the structure is, one of the design is the process that is represented with the process box that is represented with the rectangle. The next is a decision. That decision symbol represents the alternative condition that can occur and that the program must have a manner of handling. Yes, this is very good. This is equivalent to the if then else structure, if then else loop that is used in the programming language. That is, if the condition is true, then the statement will arise or then the statement will execute. Otherwise, the next statement, that is the else statement, will execute. Same, that is a decision making. So the decision symbol represents alternative condition that can occur and that the program must have a manner of the handling, and they show the equivalent of the if then else structure that is common in many programming languages. And as examples will show, the decision symbol may also show the actions for more than one alternatives at the same time. If there are more than one alternative, that is known as a decision, that is represented by the diamond shape. Next one is the iteration. Iteration means how many times it will arise. That is the repetition of the symbols, repetition of the operations. So iteration symbol represents the looping and the repetition of the operations while a certain condition exists or until a condition exists or until a condition operates. That is iteration. That is meaning is a looping, and the form of the iteration symbol that clearly specifies which iteration will be used, whether we are using or whether we are going to use iteration for the 5 times, 4 times, 3 times, whatever the demand that is required. And the left-hand portion of the symbol shows the path of the repetition to follow until the conditions controlling the iterations are satisfied. So these are the 3 symbols that is used in the flowchart. So one is a basic element, that is a process, then next is a decision, next iteration. Next one is how to use these flowcharts. So structured flowcharts uses no arrows, no continuation on the separate pages. Each flowchart is shown on a single piece of paper. So this is one of the limitations, that each and every flowchart is shown on a single piece of paper or a single display screen if it is developed online. And when designing a system on a paper, we can move the cursor, we can move the diagrams to the next line. And when designing a structured flowchart, the system analyst specifies the logic in a top-down fashion. And the first consideration that is used in a process or a decision is the top element, and next is the sequence that is shown above and so forth. That means we are going to cover within the module, within the next module, then next module and next module. In the same way, there is no single exit from the process. We have to move first of all to the upper portion, then next upper portion till the final portion. And the analyst begins with the major decision or major process and introduce other symbols to subdivide the process. And each process is named, but if the name is not underlined, it is referenced to the same diagram or same other diagram or the description. This simple convention makes it possible to link together easily possible procedures that are performed in a category or that are performed in a completion to make an entire activity. And the structured chart also reads from the top to the bottom and left to the right. Each activity is nested, each activity is inserted within the iteration and the alternative processes of which it is a part. And in addition, the condition is also clearly shown in the diagram. and each activity is nested within the iteration, and the alternative processes is also taken out, it is a part. In addition, each condition is clearly shown. Individual parts of the processes are often further described in a low-level diagrams, and the individual modules are refers to handle the processing. The same line that is available for this one. Now, what is the main importance? What is the main advantage of using the structured chart that is used for the designer that concerned about verifying the system specification against a planned software logic to identify? That means whatever the specification, whatever the logic that is available for the specification to the employees, that is used with the software logic to identify the conditions and the procedure that is followed when the condition exists. And the fact is that the structure chart is so easy to read that will enable the analyst to determine whether the debit adjustment transaction is carried out or not. For example, that has been added by the programmer or is a part of the original system specifications. Next one is a HIPPO, that is a hierarchical input-output process. That is the full form of HIPPO that is developed by the IBM. Now, tell me the full form of IBM. This is a great organization that developed multiple techniques, multiple softwares. So can anyone tell me what is the full form of IBM? Yeah, correct. The full form of IBM is the International Business Machine. This is the organization that provides this HIPPO, and this is used for the large complex operating systems. So next one after the flowchart is a HIPPO that is developed by the IBM for developing the system softwares. Now, what is the main purpose of using the HIPPO? It is based that it is easy to lose track of the intended function of a system or component in a large system. That means it is easy to track the system, track the function that is available or for the system that is available for the components in a large system. This is one reason why it is difficult to compare the existing systems against their original specifications, and why these failure can occur in a formulated manner. And from the user's view, single functions can extend the across the multiple boundaries or several modules that is used for the analyst for describing, understanding, and documenting the modules and their interaction in a way that provides sufficient detail, but that does not lose the sight of the larger picture. That does not lose the picture that is available for the HIPPO. So how can anyone explain that what is a HIPPO? So these are the graphic rather than the prose or the narrative. So these represents, or HIPPOs represent the data in a graphical format rather than paragraphs, passages, nothing. Description of the system. They assist in the analyst in answering the three questions. So what the HIPPO stores. The first one is, what does the system or the module do? That means what is the main aim of using the system? That's what does the system or the module do? Then how does it to do, or how does it do it? That is asked after or when reviewing the code for testing or maintenance. Then what are the inputs and the outputs? So when first is, what does the system or the module do? Then how does it do? In the first case, when it is a question, that when it is answered the question that what does the system or the module do, that means asked when the designing in the system. This question arises in the designing phase. Then how does? This is available for the testing or the maintenance phase. Then what are the inputs and the outputs? Ask when the reviewing the code for the testing or the maintenance. This is also used in the testing or maintenance phase. But the first one, that is what does the system or the module do, that is asked while designing the system. And a HIPPO description for a system consists of the visual table of the contents and the functional diagram. Yeah, this represents in a diagrammatical format. There is no explanation, there is no paragraphs. The main difference, yeah, very good question. The main difference between the flowchart and the HIPPO is there are multiple different diagrams. There are multiple different, we can say, the picture symbol that is used in the HIPPO as compared to the flowcharts. Next one is VTOC, that is a visual table of the content that shows the relationship between the each of the document that makes a hippo package. So that makes a hippo that shows with the table of contents that shows the relationship between each of the document, and that consists of a hierarchy chart that identifies the module in a system. What is the main module that carried out within the hierarchy, that carried out for the sake of the simplicity, that is hierarchy chart, that how different modules in a system are organized by a number, and what is the main relationship with each and every module, that gives a brief description of the module. Now, any questions till now in the flowchart, in the hippo, in the VTOC? So one of the category of the VTOC is a functional diagram. So this is a one diagram for each box in the VTOC. So we can represent the graphs, we can represent the pictures, we can represent the symbols by using the VTOC in each of the box. And each diagram shows input and the output. That is right to left or the top to bottom, measure processes, movements of data, and control points. And the traditional flowchart symbols represent the media such as the magnetic tape, magnetic disk, and the printed output. Some functional diagrams also contains the imagery diagrams. That means they contains the imagery diagram that is carried out for the external data as well as the internal data, and that can be attached with a data dictionary that is used to further explain the data element used in a process. And hippo diagrams are very effective. Why they are very effective? Because for documenting, or because of the documentation that is used with the help of the hippo diagram. And they also aid the designer and force them to think about how specification will be met and where activities and components must be linked together. However, they rely on a specified symbol that is not the same symbol we use in the flowchart. There are multiple set of the symbol, different set of the symbol that is used with the flowchart, that is used with the hippo. So they rely on the set of the specialized symbols that requires explanation or extra concern when compared to the simplicity of the hippo diagram. For example, DFDs, data flow diagram, and this is not very easy to communicate within the hippo. That means there is no easy to fetch the data or fetch the information from the hippo diagrams, and of course they does not guarantee error-free systems. But the main advantage of the hippo diagram is that for the documentation of a system. The next one is a Warnier Orr diagram, that is also known as a logical construction of the system, that were initially developed in the France by the Jean Warnier and in the United States by the Kenneth Orr. That's why this name of the diagram is a Warnier Orr. It is a name of the scientist, that is a Dominique Warnier from the France, and the Kenneth Orr from the USA. They together make this diagram, they together develop this diagram, and this method aids the design of the program structure by identifying the output and processing results, and then working backwards to determine the steps and combinations of input needed to produce them. And the simplest graphic method that is used in the Warnier Orr diagrams makes the level in the system evident and the movement of the data between them vivid. That means that makes the system as a controllable system that is used within the organization. Now, just do one thing, take 2 minutes, read out each and every diagram, each and every designing part, that is a hippo, then Warnier Orr diagram, then flowcharts. If there is any doubt, then please clear the doubts. Because next part is that is managing the quality assurance, that is very related to these diagrams. So just read it. So any doubts, anyone in this? Each and every diagram has some limitations, has some advantages. So it depends on the diagram to diagram. If I'm talking about the flow chart, that is not relevant for the hippo, that is not relevant for the Warnier Orr diagram. So it depends, or it differs from the diagram to diagram. That is, each and every diagram has some limitations and the advantages. Any other doubts? Yeah, so if I compare the diagrams, the first one is flowchart that is used to explain the logic in the program, logic of the program. The next one is a hippo that is used for the documentation, and next one is a one-arrow diagram that is used to display the output, identify the output, display the output, or we can say show the output. That is a one-arrow diagrams. So the next part is managing the quality assurance, how we can manage what is the quality assurance and how we are going to deal with the quality assurance. So quality assurance is the review of the software products and related documentation for completeness, correctness, reliability, and the maintainability. So whenever we are talking about the quality assurance, that is a review of the software products and the related documentations for completeness, for correctness, for reliability, and for maintainability. And of course, it includes assurance that the system meets the specifications and the requirement for the usage and the performance. That is how we can perform, how we can meet the specification, how we can do the requirement for the usage or for the performance. So in simple terms, quality assurance means we are sure that quality is very maintainable, quality is correct, we rely on the quality, that is a quality assurance. So it is a review of the software products and the related documentations for the completeness, correctness, reliability, and maintainability. And of course, it includes assurance that the system meets the specifications and the requirement for the users or for usage and the performance. Now, what are the various levels of quality assurance? So there are 4 levels of quality assurance. One is a testing, then verification, validation, and certification. So first part is a testing, the next part is a verification, the next part is a validation, and the last part is a certification. So let's talk about one by one. What is the testing, what is the verification, validation, and the certification? Joseph, just wait for 5 minutes, then take a break. So let's talk about the testing. So testing is very expensive, but the critical process. That means the cost is very high in the case of testing. That cost may be a labor cost. That cost may be in the terms of money. So it is an expensive but critical process that take as much as 50% of the budget for program development. This is 50% of the budget that is used for the program development. And the common view of testing held by the user that it can perform to prove that there are no errors in the program. There is no error in the program that is used to occupy, and this is virtually impossible since the analyst cannot prove that the software is free and clear of the errors. No one is perfect. That may be an analyst, that may be a developer, no one. So there must be a error. That is, there have to be errors in the software development. Software testing is very much required in each and every system development phase. Therefore, the most useful and the practical approach is with the understanding that the testing is a process of executing a program with explicit intention of finding the errors, that is making the program that helps to avoid the program or making the program as a failure program, or that is used to make the program as effective and the approachable program. And the tester, who may be analyst, programmer, or the specialist trained in software testing, is actually trying to make the program fail. And the successful test then is one that finds an error. And the analysts know how effective testing program should be used for making the test or for testing the programs. And reliability is a design issue in the analyst phase. Therefore, reliability must be designed into the system, and developers cannot test for it. And the developers may not be able to test for the currently using program that is available within the testing phase. So first part is over, that is the testing. The next one is the verification and the validation. Both are related with each other. So please listen. One line is very efficient for the verification and the validation. Verification occurs at each and every stage of the system development, and the validation occurs at the end of the software development life cycle. That means verification is initialized within each and every phase of the SDLC, which is each and every phase of the software development life cycle. But if I'm talking about the validation, that occurs only when the software is developed, only when the product is available. That is a validation. So this is the main difference. So please make a note of it, that verification at each and every level, validation at the end, nothing else. If this is okay in your mind, then everything is okay. So any doubt in these two lines, verification and the validation? Verification in each and every phase of the SDLC, validation at the end of the SDLC steps at the output or when the system is developed. So like testing, verification is also intended to find the errors, and executing a program into a simulated environment that also performs it. And the validation refers to process of using the software in a live environment in order to find the errors. That is a validation. So one is a verification, one is a validation. And when the commercial systems are developed with the explicit intention of distributing them to the dealers for sale or marketing them with a company or through a company, there's the on-field offices that must go through the verification, sometimes known as the alpha testing. Just wait for 2 minutes more. That is known as alpha testing, and the feedback from the validation phase that generally produces a change. That means there is a change in the production, there is a change in the software to deal with the errors. This is nothing in the detail, we are not going in detail, but the main crux is that verification at each and every phase. That means, for example, if we are performing the verification and if there is an error in the designing phase, so we cannot further proceed to the testing phase, development phase, no, because the error occurs at the designing phase, so there's a wastage of time if we go further for the for the next stages. So we stop there, correct the errors, rectify the errors, find the errors, and then move to the next phase. So when it is used for the verification, when it is used for the then feedback from the validation phase generally produces change in the software to deal with the errors and the failure that are uncovered. And then a set of the users or user sites is selected, then put the system into use on a live basis. And these beta sites uses the system in a day-to-day activities that they produce for the live transactions and produce a normal system output. And when we talk about the system in live, that is very sense of the word, except that the users are aware that we are using the system that can fail, and but the transactions that are entered and the person using the systems are real system. That means there is a validation, there is a verification, and the verification is done at each and every stage of the SDLC, and the validation is done at the end of the stage. So validation may continue for the several months. There are multiple months that is used for the validation, and during the course of the validation or validating the system, failure may occur and the software may be changed or software will be changed. So we have done with the testing, we have done with the verification and the validation. Next is the certification. Software certification is an endorsement of the correctness of the program. That is an issue that is arising or that is rising in importance for the information system applications. So we are certified whether the system is correct or not. That is an endorsement of the correctness of the program. That is an issue that is rising in importance for information system applications. And there is an increasing dependence on the purchase or lease of the commercial software rather than on the in-house development. So there is an in-house development for the commercial lease, for the commercial sites that is used for the commercial software. However, before analysts are willing to approve the acquisition of a package, they often require the certification of the software. That means they often require the ISO certificate, that is a certification by the user of the software, by the developer or the unbiased third party. For example, selected accounting firms are now certifying that a software package in fact does what the vendor claims it does and in a proper manner, and to do so, certify the software the agency appoints a team of the specialists, that is a group of the specialist persons who carefully examine the documentation for the system, who carefully examine what we want to for the documentation, what we require for the documentation, that is the analysis of the documentation. Then they test the software against those claims, and if no serious discrepancy or the failures are encountered, they will certify that the software does what the documentation claims. That means software is performed well documented, or software is able to do the well documented task, that will certify that the documentation will be claimed or that the software will be claimed. They do not, however, certify that the software is the right package for a certain organization. But the responsibility remains lie on the analyst part or the team of the analyst. That is the certifications. So now tell me, any doubts in the testing, any doubt in the verification, any doubt in the validation, any doubt in the certification? So any doubts? So just